Welcome to the deep dive. Today we're looking at something really specific, a piece of high-end gear. It's the Kramer CP-AOCH 6131 Active Optical HDMI Cable.
Right.
And our mission really is to figure out what this thing is, why the 131-foot version costs almost $400, and what kind of huge problem it's designed to solve.
Well, the huge problem is, it's just physics, right? If you need a perfect 4K signal, and by perfect I mean 4K at 60 hertz with 4.4.4 color.
That's the uncompressed stuff.
The pure uncompressed signal. Over a long distance, a normal copper cable just can't do it. The signal degrades, it attenuates.
Just drops off.
This cable is specifically engineered to stop that from happening, to guarantee the full 18 gigabits per second all the way up to 100 meters. That's 328 feet.
Okay, that price tag immediately says this is mission critical. It's for
Okay.
jobs where it absolutely has to work. So it's got to handle HDCP 2.2, HDR, all of it. But that brings me to a question. If copper is the problem, why not just use pure fiber optics? Why call it active optical?
And that's the core engineering challenge, and it's where the money goes. Pure fiber is amazing for bandwidth, for the video signal itself, but it can't carry power, and it can't handle those low-speed communication handshakes that HDMI relies on.
You're talking about the brain of the connection, the part that makes the devices talk to each other.
Exactly. This is a hybrid fiber cable. So you have the fiber strands carrying that massive 18 Gbps video signal, but inside the same jacket, you have copper wires carrying power, and crucially, the data for things like EDID.
EDID, that's the conversation between the screen and the source, right?
The instant conversation. It's what tells the source device, hey, I'm a 4K display, send me a 4K signal. If that handshake fails, you get nothing.
So it's the best of both worlds.
Right.
You get the speed of fiber, but you keep the functional reliability of copper for all the important control stuff.
And you get a huge side benefit.
Yeah.
Almost zero risk of EMI or RFI electromagnetic or radio frequency interference. It's just an incredibly clean signal path.
And looking at the specs, it seems built for big, serious installs. It's Plenum rated.
Yeah, which means it meets fire safety codes for running in air handling spaces, like above a drop ceiling in an office. It's also TAA compliant, which is a big deal for government contracts.
Okay, let's switch gears to the physical install, because the tech is one thing, but how do you actually pull a 131-foot cable through a tiny, crowded conduit without breaking it?
And that right there is the aha moment for any installer who's ever done this. A normal HDMI head is big, it's clunky, it gets stuck.
A total nightmare.
A total nightmare. So this Kramer cable has micro HDMI ends, but it comes with detachable full-size HDMI connectors. You just take the big head off.
Oh, that's clever.
It's genius. You're left with this tiny micro HDMI end. You run the incredibly thin cable, it's only 3.4 millimeters in diameter, through your conduit, and then you just screw the sturdy gold-plated connector back on at the end.
So you need a much smaller hole. And it mentions a bending radius of only 6 millimeters. That is incredibly flexible.
It's all about making the impossible install possible. It's for places where failure isn't an option, a corporate boardroom, a university lecture hall, places that need perfect 4K video and pristine audio like Dolby True HD.
But this precision leads us to a really, really critical warning. The source material is very clear about this. It says these cables are for point-to-point use only.
Yes. This is non-negotiable. It means no wall plates, no extra patch cables in the middle, no couplers.
Well, what happens?
The second you add another connection point, you create a potential point of failure. You risk ruining that perfectly managed signal integrity that lets you send 18 gigs of data over 300 feet. It needs a clean, uninterrupted run from the source straight to the display.
That's a fascinating summary right there.
Mhm.
We have a product that is physically engineered to be incredibly flexible. It's thin, it has detachable ends, it can bend all so that it can be electronically rigid.
Precisely. It has to maintain that perfect, unyielding point-to-point connection.
Which sort of leaves us with a provocative thought for you to chew on.
Right. We've seen that to get this flawless, long-distance 4K signal, your setup has to be perfect, point-to-point, no compromises. So it makes you wonder, in these complex modern installs, is the real limitation not the technology itself, but our own human desire to adapt things, to add one more connection, to find a workaround instead of sticking to the perfect path?
The pursuit of perfection always demands precision. Now, that is all the time we have for this deep dive. We'll catch you next time.